So hi everyone, my name is Dr. Melanie Boudreau and I'm a postdoctoral associate at Mississippi State. And today I'm going to be presenting to you some of my work that I've been doing in conjunction with the Missouri Department of Conservation, working with their black bear population. Okay, so today we're going to start by talking about these large carnivores that we have. We know that over the last couple centuries, substantial population declines and extirpation of large mammalian carnivores has occurred globally. Indeed, of the largest members of the order Carnivora, 61% are listed as threatened by the IUCN, 77% are experiencing continuing population declines, and 54% occupy on average only half of their historic range. Population declines are typically the product of multiple concurrent human-based threats, including habitat degradation and loss, overharvest, persecution, and depletion of needed prey. And the loss of large carnivores is of concern, given their key roles in mitigating disease, altering biogeochemical processes, promoting ecosystem resilience to invasive species, and augmenting biodiversity through trophic control of herbivores and mesocarnivores. But despite the need for large carnivore recovery because of their importance in our ecosystems, carnivore restoration to ecologically effective densities continues to be challenging given ongoing real and perceived human carnivore conflicts. But it's not all doom and gloom. We do have some success stories. Habitat restoration and species conservation efforts have facilitated population recoveries for species such as gray wolves, cougars, American black bears, brown bears, and Eurasian lynx. In North America, however, we have a problem. Concurrent to habitat restoration efforts over the last half century has been this rapid expansion of urbanization, leading to large areas of suitable habitat lying near or even inside human communities. But it's not just the amount of suitable habitat we have available. We also have to think about the spatial distribution and configuration of that habitat, given that large carnivores depend on landscape connectivity for natural ranging and dispersal behaviors. So we kind of have this trifecta of things coming together. Now we have communities which are not only surrounded or inundated with suitable habitat, but may also be within areas of high habitat connectivity. This, together with the ability of large carnivores to tolerate moderate levels of human disturbance and use anthropogenic foods to subsidize their diets, allows large carnivores to coexist within human-dominated landscapes, increasing the likelihood of human-carnivore conflicts. And overall, public tolerance for carnivores is typically lower within communities. So think about the last time a carnivore made the news. Usually those end up being articles on carnivores within city limits. So as such, reducing human-carnivore conflicts within communities should be a priority. However, there remains relatively little insight in the risk of conflict given the amount of connected, suitable habitat around populated areas. And such an understanding could aid in predicting which communities should be prioritized for proactive management and outreach as large carnivores recolonize their historic ranges. So with all that in mind, my main carnivore of interest for this study was the American black bear. Black bears are widespread on the North American continent until the late 19th century. However, due to overharvest and habitat loss, they became extirpated from approximately 41% of their historic range, which much of that range contraction occurring across the contiguous United States. However, with several translocation efforts in the mid-20th century, along with natural growth and recolonization of remnant populations, black bears are recolonizing large portions of that range. In fact, growth rates after 1980 are indicative of expansion, and within the last decade, there has been documented establishment of new breeding populations. So there's an increased need to minimize human-bear conflicts to effectively maintain reestablished black bears. Not only are there more black bears, conflict frequency is further exacerbated by black bear tendencies to use anthropogenic resources in exurban spaces to subsidize natural foods. In fact, some state agencies now spend more time dealing with bear nuisance complaints than all of their animals combined, resulting in an increased effort in public education and mitigation of conflicts. Given that efforts can be quite costly, it's thus critical that we use quality information to help prioritize communities which may have a higher likelihood of conflict in the face of recolonization. So one of the places this is needed is Missouri. Within the state, black bears were believed to be extirpated around the mid-20th century. However, a small remnant population remained and has grown with the help of bears reintroduced into Arkansas. This population has increased from around 280 individuals to between 540 to 840 individuals. And at current growth rates, the population is expected to double every decade. So within the state of Missouri, most bears are located in the southern portion of the state in prime large tracts of forested land, but it is expected that black bears will eventually occupy areas throughout the entire state. So we wanted to see if we could predict which communities Missouri would have more conflicts, based on landscape attributes such as habitat suitability and connectivity. So we predicted first that as habitat suitability increased in and around communities, so would the number of conflicts, and that conflicts would occur mainly within towns located along areas of greater landscape connectivity. To try to understand and predict which communities would likely have human-bear conflicts, we needed 3 key pieces of information. First, we needed movement data. So from 2011 to 2018, staff in the Missouri Department of Conservation captured and GPSed collar bears in the southern third of the state. And after removing locations from that data set that were clearly incorrect, locations that equated to distances not traversable by a bear over the time between the fixes and denning periods, we were left with just under 150,000 fixes to work with in our analyses. The second thing we needed was landscape variables. Landscape variables which are known to influence bear presence in some way. And we used human density, distances from roads, forests and shrubs, the degree of landscape fragmentation, and a seasonal vegetation productivity index. And these variables were paired with the GPS information to allow us to examine habitat suitability and connectivity. And finally, we needed conflict information to examine landscape attribute conflict relationships, and the Missouri Department of Conservation has been collecting conflict reports since 1991. So with all this information in hand, the first thing we did was produce our habitat suitability map. To do this, we input our variables of interest along with our GPS locations, which were paired with pseudo absences, into an ensemble model. So simply put, an ensemble model takes an average of models produced from different algorithms. As different algorithms may over or underestimate the amount of suitable habitat, when we average these things, the results typically increase overall accuracy. So in our case, we ran a generalized additive model, a maxent model, and a generalized boosting model. Variable weights indicated that black bears were more likely to occur in areas with increased forest and shrub cover, lower human densities, and greater spring vegetation productivity, which would result in the indicated map that you see here of their distribution. Additionally, a likelihood threshold indicated that approximately 30% of the total area of Missouri was really suitable for black bears. Okay, so that suitability map was the basis for our connectivity model, as less suitable areas are more resistant to movement and vice versa. So by inputting our suitability map into CircuitScape, a program which calculates potential animal movement across the landscape as a function of landscape resistance, we were able to calculate the likelihood of an individual moving at random throughout Missouri. Our analysis indicated that the highest levels of connectivity were located through south central portions of the state, but there was also potential for bears to move easily to more northward locations. Okay, so now that we know more about habitat suitability and connectivity, we then examined conflict records. We had 496 conflicts reported to the MDC since 1991, and we separated those into conflicts within or around communities and those in rural areas using a proximity analysis. Of the 496 conflicts, we found that 233 were located within communities and that most conflicts were related to food, things like bears accessing trash, birdseed, various types of other animal feed, beehives, gardens, crops, and human food. There was also instances where bears were simply on property or causing property damage or interacting with pets and livestock directly, and very few cases of conflict were related to natural bear behaviors such as aggression, curiosity, or denning. We also saw that while there was a lot of variation in the number of reported conflicts year to year, overall conflicts are increasing in Missouri as the bear population continues to grow and expand, with the most of that conflict increase occurring within the last decade. And we can also see that conflicts within communities follows the same trend over time. Compared to communities typical of Missouri, communities reporting conflicts were 4.7 times larger and had 2.5 times the median human populace. And all communities with reported conflicts had less than 0.1 bear conflicts per capita, with 32 and 42 communities having less than 0.01 and less than 0.001 conflict per capita, respectively. The most conflicts in a single settlement or community was 13, with 80% of those conflicts happening during the final years of our study. Okay, we looked at the potential relationship between conflicts and landscape attributes within communities, including the average distance to suitable habitat, average habitat patch density, area, or aggregation, the total amount of suitable habitat, and the average connectivity. And we found that conflict magnitude was related to the presence of large amounts of small, densely aggregated patches of suitable habitat for communities within areas of greater connectivity, while conflict occurrence was related to large amounts of aggregated patches, again, for communities within greater areas of connectivity. So with those two models, we then ranked communities as being areas which may benefit from outreach based on the natural breaks in predicted model values. And we saw that both conflict landscape models captured 84.8 or 82.5% of the communities which reported conflicts. When we prioritized communities based on the relationship between conflict magnitude and landscape attributes, 494 communities were identified as potential areas which could benefit from bear management and outreach. However, when we combine that information with the conflict occurrence model, we then only had 105 communities which were identified, which further focused our outreach priority areas. Okay, so just to summarize everything we talked about, public tolerance can be a large driver behind conservation decisions, given that despite known ecological, societal, and economic benefits of large carnivores or large investments into outreach, carnivore recolonization could still face many challenges from societal pressures. So an important criterion in the success of carnivore reestablishment is to maintain a low level of conflict with humans, given that conflicts promote negative attitudes and lower public tolerance. Avoidance of conflicts can be achieved, however, through proactive conservation measures. So you think about outreach and education. Given the limitations of conservation funding, we show here that these efforts can be focused by understanding the landscape community conflict interface. So by focusing outreach and management efforts, we can ultimately prepare those most likely to face conflicts with the attitudes and actions for carnivore coexistence as they recolonize their historic ranges. So with that, I would like to thank all the state biologists and technicians at the Missouri Department of Conservation for putting in all the many hours needed to gather this information, along with our partners in New York, whose efforts helped lay the foundation for this work. And of course, I'd like to thank all our funders, and I would love to take questions at the discussion period.